Hello, everybody, and welcome back to our next backend stream. Yeah, the last one was 4 weeks ago.
Yeah.
So maybe we should start with a small recap. And yeah, and as the title already says, we continue with Helm charts today.
Yeah.
Yeah. So
as always, we want to work on our Quarkus stuff. If you remember last time, we worked on Helm charts. So what are Helm charts?
Moritz, thanks for the subscription.
Cool, thanks.
6 months.
Oh, wow. So Helm charts. What are they for? We want to deploy our backend, our BFF, to Kubernetes. So that's running on our server, and we can call it from there. To do this, we need to deploy it to Kubernetes. And if you remember, Kubernetes works in a way that you describe to Kubernetes what you want, and it makes it happen.
Yeah.
So if we...
Yeah, we saw that last time.
Yeah. And we have a look at this deployment file. Again, this is an example from the Kubernetes docs. Here we define the Kubernetes API version. That's not so important. We say this is a deployment. So there's different kinds of stuffs. For example, service, which is basically a load balancer, and ingress, or for making it accessible from outside, and so on. Then we have some metadata, which is basically to describe what is here. And then we specify what we want. In this case, we want 3 replicas, so we always want to have 3 instances running. We say here in the template how it's built. And exactly, we want to have containers, and we want to have an Nginx container. This is just a name. This defines the image that we want from to be pulled. By default, it would pull it from Docker Hub. But you can also use your own registry. And we also define that it exposes this port 18. And when you run this, you have 3 new Nginx pods popping up with this configuration. Thanks for the resubscribe.
Yeah, thank you.
Crene. Yeah, so that's basically the idea of Kubernetes. When you would now change, for example, here this 3 to a 2 or 4, and you just update this config, then Kubernetes will update the containers to reflect this. So, or when one container dies, then it sees, oh, you say you want 3, but there are only 2 running. Then it starts up a new one to make the reality look like the config again. That's the main principle of Kubernetes. You define your wishes, and it tries to fulfill them. And now we want to define our wishes. So we have created a Helm chart with Helm create or something. I don't remember the command. I always have to Google it. I use it too seldomly. But you can create a default Helm chart, just give it some name, and you get like this template here. In here, we changed some stuff like in the chart YAML. This is like the description, the main description. We changed the name, description, and so on. Basic stuff, you can also version your app and this Helm chart.
So the app version would be then the client version?
No, this would be what you are running with this.
Okay.
So basically our movie time, a BFF version.
Okay, but then the version and the app version, should they be the same then? Or...
This is the version of the Helm chart. So this might not change. Also, you change your backend.
Okay.
Because yeah, the Helm chart is something separate. For us, this is not so important. This is more important for example, for the Postgres here. So we added a dependency. We wanted Postgres from Bitnami on charts. Postgres. Let's have a look there. So there's a ton of charts from Bitnami. I should add Helm to the query. And not the HA version. This was the high availability version. There's also the not high availability. So this is basically the Helm chart that we define here as a dependency. And in this case, they have, this is the API version.
The app version is row number 4.
The app version is this, and this is the version of Postgres
that
it's running. And here down here you see the version of this Helm chart. So the Helm chart might also follows semantic versioning. So they might add some new required fields, and then it wouldn't work anymore in your CI if you have required parameters, or it might change your whole infrastructure. Because they follow a new setup or so, then they would update this here with a major version.
So that's basically the version when you do major changes in this file then?
Yeah, in this
YAML
template.
File, or in this whole template, when you add dependencies which need more configuration and stuff like that, then you would increase the version number for the Helm chart.
And I can also, I can define which Helm chart version I want. I have now said here that the minor version I don't care, or the patch version I don't care about. Because if there's just a small patch or bug fix, go for it. But I want to stay on this version just to not have any breaking changes. Exactly. And the Postgres version that it uses is then defined in the app version. So that's why you have these two version fields. Then when you do this, you need to do Helm dep install. Dep update. Again, I do this too seldomly to remember. So with Helm dep update, you update the dependencies of this. And now you see here the chart log file has changed. So those of you who have ever worked with NPM or so, they also know this log file. In here, they basically define the exact version that you have used. This is important for CI. And it's because in CI, you want to use exactly this version to have a reproducible build. So that when it breaks once, it always breaks, and when it worked once, it always works. Because if this doesn't work, or if it changes all the time, then you get crazy. Okay. That's about the database. Then we have this values YAML. This is basically how we configure our Helm chart. Here we can define variables that are then injected into our templates. If you remember, Helm is just a templating tool to put variables into your Kubernetes definitions. And I showed you before the deployment YAML on the Kubernetes docs, and that's how it looks here in the templates directory. And this double braces is the syntax they use for including templates and stuff. So here they include a function. It is, where is a variable? Nice one.
Yeah, basically the double curly braces are normal templating stuff. When you do web development or something like that, or it's basically the same. The template engines there also use the double curly braces, and then
just wanted to check in the config map. Here we have some. So you can also click on it if you have the Helm or Kubernetes plugin installed in IntelliJ.
So these values are for now only placeholders?
These are only placeholders here for now, some of them. So username and password of the database, you probably want to have a different one. Probably even different between each stage. So we can later specify this. What we also need to set is our API key for the movie database.
Yeah, for the API.
Yeah. And you can basically put in everything here. And here you can write it however you want. And later you can use it. For example, this API key, I put it under config, MovieDB service, and API key. But this naming is completely free. I can do it like I want. Normally you would do here would use environment variables here or something like that, because you don't want to put the API key, for example, under version control and stuff like that. Or? Exactly, that's why I haven't specified it here. And when we run this, so for example, when we run it like this.
Can you put it, move it a little bit up, or yeah, perfect.
Okay. I can also increase the font a bit. Editor. Yeah.
Yeah, I think it's okay from the font size.
So to install this, we first have to connect to Kubernetes with our kubectl. You remember, we can do something like kubectl movie time. This is our namespace, get pods, and I see my 2 pods running. This is our BFF, and this is our database. And if you have this running, then you can use Helm. Helm here, and basically we tell Helm, please upgrade the existing Helm chart with this name, or install it if it's not there yet.
Okay.
There's also an install command, but it doesn't work if it's already there. This one with upgrade -- install always works. And then -n specifies the namespace. Then we specify the path to the Helm chart, which is
where the template is. Yeah.
Where the template is, yeah. And now with this, I can set variables. Now I set config MovieDB service API key. If you remember, config MovieDB service API key, and it should be this value. I have this environment variable defined on my machine, so I read it. For those who wonder what the crazy syntax is, it's PowerShell.
Yeah, so basically on a real system, this would also come from an environment variable.
Yeah,
like that. Yeah.
Yeah. For example, if you use GitHub Actions or some other CI, then you also inject these secrets.
Yeah.
And then you use them like this. And if we run this, then basically we replace this value here. And we have this value here in our secret YAML. So this is how we can define secrets. Remember, they are not really secret or encrypted or something. They are just base 64 encoded to be able to store special characters in YAML, because YAML uses, for example, the colon and stuff.
Yeah.
And it's just that you can give roles, and some roles have access to your secrets and some don't.
Yeah.
And basically here we say we want from the values file, we want config MovieDB service API key, and we put it in here. And that's all of it. That's how Helm works. Same happens with the database password. And for the non-so-sensitive stuff, we put it in the config map. And yeah, specify it like this. So that's basically what we had last time.
And last time we also used a repository in your user account, because that was we had the issue that from the company GitHub account we haven't had the rights. So that's why your user account is up there. Exactly,
that's why this user account is used here. And my preparation repository, where I prepare usually the streams. thing is, I still haven't changed that setting.
Yeah.
So we're still gonna use that. Okay. So
that's basically what we did last time.
Yeah.
Yeah. So
any questions so far? Now is your chance.
So otherwise,
yeah,
the new stuff.
The new stuff. So when we execute this Helm thing here, then we see it's deployed or it worked. We can also do like get pods.
And we see one is running and
database is creating. So
okay.
Something changed. Yeah. You know what changed? I updated the database container to the newest version. So now we also have the newest security fixes and stuff.
And then Kubernetes automatically recreating all the stuff.
Yeah. So at the moment we only have one database pod running, and since databases they use they need to store data, and that's why these are stateful sets and not deployments, because they need to run on a certain node. Because if the memory is, or the storage is there on this node that you have quick access, then you need also to run the right pod there. That's why you have stateful sets, and that's why it's recreating it. But first has to shut down the old one, and it cannot just have start a new one on another pod. So now we are running again. Okay.
So on a real system on production, you would have more nodes of the database, and then Kubernetes would automatically exchange all the nodes?
Yeah. Okay. So you have multiple pods then on multiple nodes, and Kubernetes would shut down one, recreate it, and then shut down the next.
Okay.
And your Postgres high availability, this is the other Helm chart I showed. It has multiple, and it will notice, oh, some pod is gone. Yep. So it rebalances and does its magic.
So there's more configuration in it, in the high availability thing.
Actually, it's not that much. So maybe we can try later.
Okay.
Just to use it. Okay, that's one thing. But in real production, you would not run your database in your Kubernetes cluster on your own, because maintaining databases and so on is not so easy. And if you want to really scale it, just use the one from your cloud provider. Okay. Like Azure has its Cosmos DB, RVS has some databases and so on. And they have like one cloud database, and it supports MySQL, Postgres, Mongo, whatever. So you can just use it with your driver and be happy. And they know how to scale.
Yeah. So you wouldn't do that by yourself. So
yeah, it's something for a dev cluster where you don't, or staging or so. It's you already have the cluster. You don't have a big load, so you don't need to scale, and you don't care if the data is gone.
Yeah. Okay. Then so for testing or development purpose.
Yeah, exactly. Yeah. And then it's cheaper than using the
cloud
stuff.
Database stuff.
Yeah.
Okay.
So, first of all, we would like to make our service accessible from the outside. So for this, not this one, there is Ingress. So maybe I can show you in Lens. This is Lens Kubernetes. It's like they say it's an IDE for Kubernetes. So it just, what you can do with the command line, you can also do it here, but visually.
So it's basically a UI for the command line stuff.
But and you can also like with one click see the logs. Like you can also connect to the command line on the pod. So now I'm on the pod with this command line. So this is really nice if you want to look at things. You can also there's the pod, but I can go to the deployment and just say yeah, give me 4 of them.
Okay, and then it rescales.
Yeah.
Okay.
So you see Quarkus is super fast. It's already started up. Yeah. So that's what stands for. What we already have created is this. So we have these pods, and we have a service. This is a movie time BFF service. Also, the database has some services. And you always access something via a service, because this is basically a load balancer.
Okay.
This service just does a round robin load balancing to all of the pods for my movie time BFF. So because this is a stateless service, it can just do a round robin load balancing, and it doesn't matter if I would access it from outside or inside. I have to go through this balancing to just reach all of them. And the service, for example, when one is shutting down, then it will, when it's here yellow, then it will notice, oh, this is not ready, and it will not send requests to it.
Okay.
It will automatically remove pods, add pods, and so on. So, but the service is just an internal thing, and we need to make it accessible from the outside world.
Okay. So you have to map an API call and address from the outside to the inside, so to say.
Yes. So for this, we have an Ingress installed in the cluster. There's also a Helm chart for Ingress. But again, if you have a cloud provider, they have something like this installed, or you can set some check mark and you get it.
Okay.
Yeah. So in our Helm chart, there's already preparation for it. There's this section here, and there's also this Ingress YAML here.
Okay,
with some
a lot
config.
of stuff. Yeah.
It always looks very bloaty.
Yeah, it's if else and stuff like that. Okay.
Yeah, because here, for example, it checks if the version of Kubernetes is higher than 1.19, because in 1.19 they changed the API version for the Ingress.
Okay.
And for example, this changed here. This is the new way to define it. This was the old way.
Okay.
That's why they have this if else in here. Yeah. They are compatible with a lot of versions. Also here 14 and so on.
So the resulting YAML is
much smaller.
Much smaller than that.
Yeah. So we need to define this. So first we need to enable it. And yeah, then the class name. This is something that is also configured in the cluster already. We have an Nginx Ingress installed. There are other Ingress types, but basically this one is based on Nginx. If you define this class, which is a newer thing, then you don't have this.
So basically the Ingress thing is the load balancing or just the mapping?
This is just mapping outside world to some service.
Okay.
So this is mapping it to this service that we have in our for our config here. Okay. Yeah, that's basically it. And the service is doing the load balancing.
Okay. So that's just the mapping.
Yeah.
So okay.
Yeah. So what we can do this later. So first we need to define how we want to be reachable. And for this, we're going to use this. This is basically defined. This is our cluster for research project. And this, everything that is under this subdomain is directed to this Ingress, to the Ingress in our cluster. And now we basically define one root, and we say movietimebff.dev under this. Everything that goes there should be redirected to this service. Yeah. So that's basically it already, I think.
And where is the connection to the service then?
So you need to keep in mind, this is only defining what you need to define. This is only the values.
Okay.
This is not an Ingress YAML.
Okay. So that's just the values, and they get pasted in the correct place.
So we have here rules.
Okay.
Then you have the host now that we placed in here. You have paths.
Okay.
And
then the service name and okay.
Yeah, exactly. The service name, and the service name is again just the name of this whole service or this whole thing. So if we look in Lens again, it's basically this movie time BFF, how we called our Helm chart. Exactly. So that's, and also the service port, and this one is from here. Yeah.
So, and this one gets activated as soon as you save, or do you have to say, okay, use it now?
So when I upgrade this Helm chart,
you have to execute the
yeah, sure.
Okay.
With Helm upgrade, I deploy this change to Kubernetes.
Okay.
So I can do this now. It actually did not crash. That's and here you now also see that this is something we have this nodes txt where we can define what should be printed here.
Okay.
And since we activated Ingress, it printed here this URL. And what we can do now
is paste this into Postman.
Into our Postman. And just go here like that, and voila, we get our movies with our API.
Cool.
So now this is HTTP.
Yeah.
Nobody likes that. We want to have HTTPS. Especially if we would send some credentials, user accounts. So this is really easy to do. What you need to do, so we have a cert manager installed in the cluster. Cert manager is just some pod that is running there, and it's listening for this Kubernetes config stuff. And whenever it sees something like this, in an Ingress file, it tries to create a Let's Encrypt certificate for you.
Okay.
But it needs some more details. What you also need is this. So it needs to know the name of the secret where it should store the certificate. Let's call it movie time BFF TLS. And it also needs to know the host for which it should get the certificate. So, and we also need to tell it which issue we want to have. So you can have multiple.
Okay.
For example, for Let's Encrypt, there's a production environment and where you have hard rate limits.
Okay.
So you cannot request too many of them, and you have a dev environment where you can request more often.
So there's a question in chat. What does the ACME or
ACME for the I don't know the exact wording anymore.
The second one, automatic certificate management environment.
Now you know it. Yeah. So basically this activates this automatic certificate renewal. Because that's also really cool.
Of course.
Obviously. I mean,
of course, it would be the second guess, yeah.
Yeah. So you might know certificates, they run out. They have a limited lifetime, and nowadays you tend to have shorter and shorter lifetimes, because if a certificate gets stolen or there's a security issue with the certificate authority, where somebody can create illegal certificates, then they are not valid as long. And that's why you always need to renew them. And if you activate this, it's done automatically for you, and you don't have to care anymore. That's like.
So the Kubernetes cluster or the
cert manager in the cluster does it for you.
Nice. Yeah.
So when we start this.
So then you could also say, okay, I want a lifetime of X days or something like that somewhere.
I think Let's Encrypt defines this.
Oh, okay.
But I'm not sure. Maybe there's also some config or so, but I have never looked into it. For me, it's enough that it works out of the box and you never have to care anymore.
Yeah, but maybe there's some parameters you can configure or something.
Probably there is.
Yeah.
So let me drop this because I tested it before. So we will start it now. Okay. It's possible. Yeah.
So
okay. Although I deleted this. So what it does is Cert Manager realizes it needs to get a certificate. It starts up a pod that handles the challenge from Let's Encrypt. So Let's Encrypt sends you something and so on. They try to verify that you own this URL or the domain. So it starts up a pod that does this challenge, and it also creates an ingress for this and so on. And then it creates the certificate and saves it here and configures Ingress to use it. So now we have HTTPS.
Oh, okay.
And it was so quick that we had no chance to see it.
And it doesn't have to restart the Ingress thing because it says lifetime 5 minutes.
The interesting thing here,
or the 8.
This is only config.
So it's just
this is when
routing.
it was first created.
Yeah, okay.
And it's not the actual ingress that's running.
Yeah.
The actual ingress is in some other namespace, some pod.
Okay.
Maybe.
So that's basically just the routing stuff, which gets updated.
Yes.
So that's why it doesn't need to create a new pod for it.
Yeah. So here's the actual Ingress pod in a different namespace. Nginx Ingress, I called it back then. And I also installed this with a Helm chart, and it's running since 300 days. Yeah.
Okay. So now you can access it with HTTPS.
Yes.
Now that should also work.
HTTPS. Yay.
Okay.
And
the HTTP doesn't work anymore. It
still works, but it redirects to HTTPS.
It automatically redirect. Okay.
Yeah.
So it's also HTTPS.
Yeah. So one thing that we can now do, so we probably want to switch between using it locally, using it remotely. That's why Postman has environments and variables.
Yeah, and we put it in environment. Yeah.
We put in host, and we have this environment, Kubernetes dev, I called it. We might have the production stage as well, running a different version. And here we have this environment, and Postman doesn't want to load it.
Environment not found. Okay.
Interesting.
So normally you would enter then
I have
the domain here.
Can you see it here? Yeah. So I have it already in there. And now we can also make this call like this. But if we start it locally again, then we can also directly switch back to local. So localhost and same, but here when you hover over it, you see that's localhost.
Okay.
Only HTTP and 1818.
Yeah, that's what I like on Postman. So you can easily configure everything and then test all the backend stuff.
Yeah.
All the calls and so.
Yeah, and you can export this, or when you have a team license, then you can share it in your team, or you can
export it and
import it,
check it into the
repository.
Git repository and stuff like that. Yeah.
I like that because then you have the code that provides exactly this API version with exactly the definition in Postman. That's very good then.
Yeah, I also like it for app development. So when you have to add API calls and stuff like that, it's every time it's cool when there's a Postman collection in the repository which you can import and then have the basic calls you need.
Yeah.
And then you can test it and stuff like that.
And not just basic, there should be everything should be in there. I mean, also you can generate Swagger docs with Quarkus. There's an extension, you just add it and then you can define some annotations.
Okay.
It creates a Swagger file and then you can import that in Postman. That's also possible. Okay, so much for Ingress. That's basically done already. One other thing I wanted to look at is the readiness and liveness probes. So if you remember, in the deployment, we commented out this one here. So let's put them in. So Kubernetes you can define two probes where Kubernetes tries to find out how healthy your pod is. So the readiness probe is there for saying, okay, I'm not ready. I cannot serve traffic, so the service does not forward any traffic there. This is especially interesting when you start up, because during startup you might need to connect to the database, to
and then
Kafka,
the node is not ready. Yeah.
And you're just not ready to serve yet. And then it's getting blurry.
Okay.
Then you then you just don't want it to be added to the load balancer, because if somebody would be directed there, the pod cannot serve this request and would fail or something.
So basically that's the endpoint which the load balancer is checking before it's routing traffic to it.
Yeah.
Okay.
So it's continuously checking this endpoint. You can also specify.
So just basically saying, are you ready? Are you ready?
Yeah, you have a failure threshold, initial delay seconds. So if you know initially it will take a minute for my super slow service to start up, then you can tell it so it doesn't have to bother it during startup.
So then it waits till this delay is over and then it begins the readiness.
Yeah, then it starts asking, are you really ready now?
Okay.
And only when it's telling then, yeah, I'm ready, then it starts using it. Okay. You can also say the period, how often it should call it, how often.
Okay, the time between the request for readiness.
Yes, exactly. Because it does it continuously, and when maybe your database breaks down and you cannot serve anymore.
Okay, so you could say 10 seconds, 30 seconds, or the time you want.
Yeah, probably.
So what is a normal time for this check? So in production,
don't know if there's how to easily find the default. So probably 1 second is
so basically really fast.
Yeah, I mean
a really short deal.
Yeah, there's not much load. If you do this once a second, it's a call once a second. That's nothing. And for the load balancer, I mean, if it has 50 pods, which would be quite a lot, then it has to do 50 calls a second, so not too much. And if it breaks down, and the faster you notice, the faster you can prevent calls going there and failing and upsetting your customers.
So normally this delay or this time span would be very, very short.
Yeah, but usually I don't even configure it because the default just works.
Okay.
But to be honest, I don't know the default by heart.
So if you just don't configure it, then it has a default value.
It has a default, yeah. So the only thing we need to configure is on which path it has to check and which port. And this is a name for the port that is defined.
And it basically checks
somewhere.
Also only checks for a status code or for response code.
Yeah, it checks the response code.
Okay, so it checks for a 200 or 200 range.
Yeah. So now we could create some endpoint, some I'm alive endpoint. Yeah.
Okay.
So there's two things. There's readiness. This is, as you said, for the load balancer. And then there's liveness. If the liveness probe fails, Kubernetes knows, okay, your pod cannot recover from this situation. Okay. You're in some broken state. Maybe this could also fail if your pod hangs, it just gets stuck in some deadlock or whatever. Okay. And it will never answer this call anymore. And then there's again a threshold, how often it has to fail until Kubernetes says, okay, you are dead. You won't recover, so I just kill you. It kills the pod and starts a new one. Okay. So
the readiness thing is when you want to deactivate the load balancer for a special node because you want to check something on it or whatever, you can deactivate the readiness.
No, you usually don't do this manually. Okay. But for example, if on your node, if the database connection is down or the database is down, then you might not be able to serve your customer again or anymore. But it also does not help to restart your pod. It only causes trouble for the cluster to do this, start new pods and so on. And it might even make the situation for the database worse. Okay. Because it might share the resources also. So you don't want to be restarted. If your database driver can reconnect and Quarkus can reconnect. So in that case, we just want to be sure we stay alive, but we cannot serve traffic at the moment. This might be a local thing. So Kubernetes runs on many nodes. Nodes are the computers where it's running. Yeah. And your node might have a connection issue. So you might just wait it out until better better things happen.
Something is updating or third-party system isn't available for some seconds or something like that.
Yeah. So no reason to kill you, but you're also not in the state that you can serve your customer. Okay. So if others are still healthy, the load balancer can still use them. But I'm currently not here for work.
So basically you would use an endpoint here where you perform checks on your node, so for third-party systems or whatever, and then calculate the result for the readiness. Yeah. So then you can say, okay, I'm ready or not.
Yeah, exactly. So, and we don't have to do this by ourselves. Okay. Again, Quarkus is awesome.
We have built-in stuff.
We have built-in stuff. So there's SmallRye. SmallRye is basically, they try to standardize some stuff you always need. Okay. And there's this Quarkus SmallRye help. So this from they implement the Java microprofile stuff, which is the standardization. And they have a health thing. They also have a Kafka thing and so on. Or a messaging thing rather. And Kafka is just one messaging service that you can use with it. Yeah. And we add this package. Also, it's time for updating again. New month, new minor version.
Okay, so every month?
Every month they have a minor version release.
Okay.
Yeah. Always at the beginning of the month, you have the new minor version, and it's not strictly timed because they have some Apache release process for some sub-projects that can take a while because they need votes and so on. But around the beginning of the month, you get a new minor version and then the patch versions during the month.
Okay.
So,
so we update these versions here and add the small array.
Yeah. So Quarkus update would not be necessary just for fun. So, and we start this. And since we are using the Hibernate from Quarkus, or the JDBC rather, we get this check for free. So we can now call
okay, so it creates an endpoint for the health check.
Yes.
Oh, okay.
Under Q by default. And here you now see status overall is up. We have a list of checks.
Okay.
And your database connection is healthy. And we could also add like other checks.
So you could basically add a check for the API we are using. So for the MovieDB API, if this API is ready.
Yeah.
Okay.
So that's the documentation for the small array health. Just to show you quickly how you can do this. You can just create a class like this. You add the add liveness.
Okay.
And then you have a liveness probe.
That's it?
That's it. You have to implement this health check interface, which just has this method. And then you can give back here it's up or down or...
So in here you would perform, in our example, we would perform a call to the MovieDB API and check the result?
Yeah.
Okay.
And if it's okay, then
we say, okay, it's up, and otherwise we say we are down or whatever.
Yeah. That's... Oops. Mistyped.
But what would happen if we have, for example, 3 nodes and the health check would say every node is not ready? What would then happen?
So if none of them are ready, the load balancer cannot serve anyone.
Yeah, then
it gives you back
our API would be not available then.
Yeah.
Okay. So because when you rely on a third-party system and this system isn't available, then every node can't work anymore.
Yeah. So that's it. I just had to convert it to Kotlin. And now we have and this is a liveness. There's also edge readiness for the liveness or the readiness probe. And now that we have this, restart.
So that would now say every time we are alive?
Yeah.
So because we don't have the opposite.
Yeah.
Because we return
always
the I'm up.
Yeah. Okay. So now here you have our simple health check.
Okay, so normally you would then enter as name movie API or whatever you call in there.
Yeah.
Okay.
Movie API.
DB API.
Movie DB API.
So you would act the system you rely on, because then you know, okay, which thing is broken. Yeah.
Yeah. And I told you in Kubernetes there's readiness. So you have a health. You can call health. So you get all of them. But you can also call health/ready. Then you get only the readiness checks. And you can call live, and you get only the liveness checks.
Okay. So you can. That's what we now want to configure.
Yeah, that's exactly what we want to use. And yeah, if you would like
down, okay.
down, then
okay.
then it's down, and you get a 503 here, and the load balancer would know it cannot use this. Or in this case, the liveness probe goes down, Kubernetes will kill your pod and restart.
Okay.
Yeah, there's also named, and then you can say settle data and so on. You can add some details. Yeah. So much for that. And now we want to use it. And we can do this with the template deployment. Here we have to say give the path.
Health and life, and the other one is then health / ready.
Yeah. So, and now we have to trick a bit, because we need a new container that has this in there, and as you remember, okay, yes, okay, I already built that one because as you remember, I have to pull the container from the other repository, but I already built it. The latest already contains this, and we want to upgrade now. So basically we just change this config, and in lens we see a new one is starting, or the old one is killed, the new one is started. And if we check here again, not Ingress, movie time pods, one of run is ready.
Okay.
Now I will, for testing purposes, I will kill the database stateful sets. So I will just scale it down to 0.
Okay.
And so when you do this, also Kubernetes send it a command to start shutting down. So starting and now received shutdown request, so it can do a graceful shutdown. That's why it's taking a bit.
So now, normally you would now do the lively down stuff, but at the moment it doesn't report that it's down, right? We only have the return type we are up, I think, or?
That was only in our custom check.
Okay.
But we have this automatic, in the readiness, the database thing comes automatic. Because we use the Quarkus database stuff, and when you use that and you use the health checks, then you get it for free.
Okay.
If you use the Kafka connection, you also get some for free. And so that's really nice. And now we see it's orange.
Okay.
And you see here the readiness probe failed. Q healthy ready. And if we would try to call it now,
we would get an error service temporary unavailable.
Search movie.
Yeah, okay.
Temporarily unavailable. And if we start the database again,
then it should become green again.
Yeah.
So now the database is started up, and when that changes to green,
so the database is starting, and you see it's still orange, not green. So this also says it has a liveness check probably. Or, now it's green. Now it's really ready.
The other thing should also get green. Soon.
Yeah. I mean,
Okay.
It's the question how often Lens is updating and so on. So, and now again we can do our calls. One thing that you usually do not want to have is to expose this, but we have now exposed it. But usually you don't want to say, okay, I'm using a Kafka database and stuff to the outside world. So that's why we need to change the base path. 1 second. So we need to change the base path, and why would we need to do this? Our ingress here, at the moment we forward everything that's coming for this domain to Quarkus, and Quarkus does not know, or it gets the request, so it serves it. So what you can do is we say we want to only forward calls that go to /API. But then we need to also, Quarkus also needs to have this /API. So we can define the base path, which looks like this. So we just say Quarkus has a root path of /API, just something that's prepended as a prefix. Of course, you can also override this in your CI if you want to, by just setting this environment variable. But I think it is a compile time config. So you cannot change it during runtime. So it's something you need to set when you build your container. Yeah. So when we have this and we go to Postman again to localhost, we make our health call. It's not working anymore. And when we make our search movies call,
it's also not working anymore.
Also not working because we need to make this API thing.
Okay.
And this now also, working here. So we gained nothing.
Yeah, just another path.
Yeah, it's just a prefix for all of them. That's not what we wanted.
Not more security or something like that.
Yeah. What we need to do is, this is a default that was made to be compatible with previous Quarkus versions. There's a separate non-application root path. This is for all the Quarkus stuff.
Okay.
So for the Quarkus dev environment or dev UI and so on. Everything that's from Quarkus and not from your own application code will be now under Q. So if we run this again.
So this would serve to the outside only the API things?
So now we basically, from Quarkus side, we just have that we serve everything that's Quarkus specific, like the health checks under Q.
Okay.
And all our API stuff under
with API. Okay.
So, and that allows us to say in Ingress, hey, only forward stuff for API to our Quarkus service. And when it only gets stuff with /API from the Ingress, then it can only serve for the Ingress the /API stuff. So
then it would be impossible from the outside to call the health stuff?
Yes.
Because everything is routed to /API?
Yes.
Okay.
Only the /API stuff is routed to Quarkus. What this says is only when you use /API, route it to Quarkus.
Okay.
Otherwise, there is no route for it, so 404, not found.
Okay. So if we then call from the outside our base URL /q/health, it would give us a 500 thing.
No, 404.
Or 404, not found. Okay.
It's not an internal error or something.
Yeah, exactly. It's not found. Yeah.
It's not there.
Okay. So, but for Kubernetes, for the internal stuff, it is available.
Yeah, because Kubernetes does not use the Ingress. It doesn't have to come from the outside world.
It's already in, so to say.
And it uses the or directly the pods, the service calls directly the pods. And also, if you would use it inside in Kubernetes from another service, you would call it over the service, and then you would have access to it.
Okay.
So we want to upgrade it. Now I had to create a new container because we added the
The properties.
The properties, exactly. I already did this in the background. So we have a new tag. This is our new tag. Now we need to specify it for the values YAML.
So that's basically for the new container.
Yes, that's the idea of the new container. Now we can say image.tag to replace it in the values YAML. And you can say this, and you can do this in CI with the tag that you just generated. And if we go back here, we see our it's restarting. You also see it's restarting on a different node. So we have a couple of nodes in this cluster.
So now it's terminating the first one.
Yeah.
That's the old one.
Yeah. And it only terminates the other one when this one becomes green and ready. Because the service needs to have someone to serve it. And
the service should be available as well.
Yeah. So when we now make the
now
call,
you shouldn't be able to call the health check directly.
Not localhost. 404 not found from Nginx, from our Nginx.
So from the outside you can check the health anymore.
Yeah. But inside it works, and we
And
can
the
still
API calls work.
use our calls.
Okay. Oh, cool.
Yeah. Yeah, that's that. I need to check if I had.
So chat, any questions? Is somebody still there? Yeah, a lot of stuff on a Friday.
Yeah, it's a lot to first get a grasp of it.
Yeah, but when you understand what everything means, then it's relative easy.
Yeah,
to
that's
configure
the
this
nice
stuff.
thing. You first have to get to this stupid syntax here
and ignore all the templating stuff here.
Yeah,
and then
just ignore most of it. Put in your values here. You can also modify it if you need special stuff, but it's also.
Yeah.
I guess this is the channel, Moritz, that you just posted for our videos.
Yeah.
There you can get your refresh the old stuff.
And there you can rewatch the first part of this Helm Kubernetes.
Any good cheat sheets? Quarkus cheat sheets.
For Quarkus Kubernetes or for what?
Helm probably. So there is a Helm cheat sheet.
For Helm, okay.
Yeah, I had one, but I need to Google it again because I have a new computer and I didn't bring my browser history. But there are some good ones out there, but I don't remember them.
But that's we can add cheat sheets, URLs or something like that to the YouTube video when it's available.
Yeah.
So we can note that on our list to add it.
Yeah, that's one thing. So one small thing that we might can have a look at. There is also, so you can specify the resources that you want to give your service, and usually that's a good idea because if your service goes mayhem and runs out of memory or so, you don't want to have it be allowed to steal all your memory.
So you can define maximum values or something like that?
Yeah, maximum and minimum values.
Okay.
The minimums are especially also important to guarantee some resources to your service that another one cannot grab the resources.
Yeah.
And so we can easily do this. Again, here in the values, there's a thing prepared already. And that's this.
Okay.
No. Request. So basically, requests means minimum.
That's what our service requests from the system?
Yeah, that's
so to say.
That's probably the idea. It's the minimum it gets, and limits is the maximum. And what we can say is that, at least it must always have 100 milli CPUs.
Okay.
So like
that's the smallest number you can.
Yeah, you can go smaller, but
Okay.
you can also say it must at least get that.
Yeah.
So Kubernetes will reserve 10 milli CPUs
For every node then.
for every pod of
Okay.
the service. Yeah. And 128 megabytes. Now we have to check if we can see it. Yeah. So we run Quarkus with the JVM, so on Java Virtual Machine, and not native build. You can also make a native build. And at the moment it uses 217 megabytes. When you use the native build, it's much smaller. The build time is longer, and the requests per second that it can serve are actually a bit smaller.
Okay.
Because the JVM is just crazy good in optimizing code during runtime. But you see, 100 will not be enough. So we could say 256 at least, and like
512 or something.
512 at most, and also 1 CPU at most. And now we can.
So, and when it wants more memory or something, then
It's
Kubernetes
limited.
would shut it down, or
Yeah.
or
So
limit it to that amount.
Yeah. It will not get more. It's basically as if you would be running on a computer with 512. If it runs out of that, probably Java just dies.
It runs out of memory.
Yeah, it runs out of memory. The Liveness probe goes down. It's restarted. But
So it's basically when you have a limited amount of memory, or you want to limit all the services to a specific amount, then you would, or on a production system, you always would define such limits.
Yeah. On a production system, you usually even make limits and requests the same for critical services.
So you don't have a span, so exact this amount.
This is the amount you get.
Okay.
And that helps to ensure that, I mean, it doesn't make sense, for example, if I put in the autoscaler and it scales to 30 pods because I need it.
Yeah.
But I have 30 pods that only get limited amount of memory, and because there's not much more, there's not more left, and a CPU that's crippled, and it starts more and more, but they should just be running. So usually you would put in the same values, and especially for the memory, it's helpful, because if we have 256 and now somebody else grabs all the memory, you can't get any more. Because there's not more left. So usually you put in the same values. It's also something Java containers like more, when they know at the start what's your limit, and then they try to stay in there.
Is it also possible to only define the memory here?
Yeah.
Also, it wouldn't make sense, but is it possible?
Yeah, it can make sense. If you have a service that's, if you want to give it all the CPU power it can take.
Okay.
But limit the memory, then it can make sense.
Okay.
I mean, let's try. So
now it's starting up the new one and then stopping the old one.
Yep. And what's the new one? It has no metrics yet.
Maybe you have to refresh it or something.
Needs a bit, because it's not like profiling all the time. You don't want to have that load. Did we limit the memory? Yes, memory.
To 512.
Okay.
I'm still not available.
So this is super not updated, 1.2 megabytes.
Okay, maybe you have to refresh, or it takes some time.
It takes just a bit, because it's not refreshing that often.
Okay.
I wonder if we can see it here somewhere. So you see this quality of service class. It's burstable, which means it can request something that you cannot deliver anymore.
Okay.
Because we don't have limits and requests set. We have now the memory ensured
Yeah, but not a CPU.
But not a CPU. So it might want to get more CPU than you have.
Okay.
So memories, CPU is now here, memory is here, and I don't see the values. I'm not sure if it has worked. Let me not logs, edit, and just have a look here in the pod description. So up here, Helm puts in some boilerplate, which we don't care about, but down here, yeah, it's in here.
Okay.
So, and I don't know why, but before Lens would display some lines here, like a top and bottom line. But let's try.
Maybe because you haven't made any requests or something like that. Maybe it just updates when the requests get executed and then.
Let's try to set both. So now you see here guaranteed.
Because you have both limited or both
configured
both that,
to be exactly what we need. Here, down here. Okay. Now I get it.
And maybe it's
up. So this is a pod, and in a pod you can have multiple containers.
Okay.
And the containers have the config, not the whole pod, but every container you might have additionally an ingress in there and
wrong part.
Yeah, we just at the wrong graph. Yeah.
Okay.
Now it takes again a minute. Memory here.
Yeah. Okay. Now we have a green one, requests, and the actual usage in purple.
Yeah. Okay. And if you would have a different limit, Jan would also see that.
And then you can see,
I'm in that range.
Am I in a good range, or do I have to increase it, or
Okay. So at the moment we are using or allocating way too much for our small service because we only have a database connection and so on. So this 512 is way too much. But if you would have like
but you can see it here.
Yeah. If you add caching and you have some in-memory caching, you need some space.
And this would increase, of course.
Yeah.
Okay, cool.
Yeah. And with that, I would say, I see it's there is at least one more episode of Helm Charts.
Okay. Still not done? Okay.
Yeah, I mean, we would like to deploy this with Kubernetes.
Yeah, okay. Yeah.
Or we have deployed it to Kubernetes, but we want to do it with CI.
Yeah,
that's what I wanted to tell or say.
So this would then happen in 2 weeks?
No, in 2 weeks I'm on vacation. So
okay.
In like 6 weeks.
Oh, 6 weeks. Okay. So stay tuned. Watch the part 1 and 2 in 2 weeks, and or something like that. Yeah.
We should make a questionnaire for the start of the stream for the viewers to have to answer everything about the old streams.
Yeah, but we can make a recap of this part next time maybe, but not from part 1.
Yeah.
So if you missed that one, you have to watch it on YouTube.
Yeah.
And okay. So no questions in chat anymore. Maybe we give the chat a little bit of time then, and I think then we would end the stream here.
Yeah. In the chat, Moritz, I think he already posted the links to our YouTube channel.
To the GitHub repository.
Also that.
Yeah.
And thanks, Moritz.
Next week, on Friday, we will have an iOS stream. And
then we see.
And okay, so no questions anymore. Then thanks for joining by. Or for stopping by, and for joining by. Thanks for stopping by, and have a nice weekend. Bye bye.
Have a nice weekend. Bye guys.